Good day, this is Dr. Wortel with a revision video on the chain rule. Okay, we're going to explain the chain rule here by an example. So what is this chain rule and how do we use it? Well, we want to use it whenever we have a variable z that is, in this case, it depends on two variables x and y. Well, this is a situation that we've seen many times in the course. But in this case, we see that variables x and y also depend on other variables. So here we see that x is a function of two variables u and v. And in this case, y is only a function of a single variable u. Furthermore, we see that u then is a function of the variables s and t, and v is only a function of the variable t. So we have a bunch of dependencies. And one example that you can use the chain rule for is now to find an expression for dz dt. And how are we going to do this? Okay, so in step one, what we want to do is we want to build a tree. And how does this tree work? Well, at the top we have the variable z. And we see that z depends on the variables x and y. So we build our tree like this, downwards. So we have x and y. And z depends on these two variables x and y. So let me also write an f here, just to denote the fact that this dependency is given by the function f. Okay, so now what I want you to do is to finish building this tree, because x and y itself also depend on other variables. So the first step is always to build the entire tree, and you keep going on until the variables do not depend on anything else, or until you've reached the final variable that you want to take the derivative of, which is t. Yeah, so first we want to build the tree. So once the tree is finished, what we then do is we take all branches from z that lead to the variable that we want to differentiate. In this case, it is t. Okay, so let me give an example. So I'm going to write this in red because this is not the true tree, but let's say x only depends on t. So this is red, so this is not correct in this case, but just as an example. Let's say we have a tree like this, where we have a branch like this, from z to t. So the next step after building your tree is you go through all possible branches from z to t. So in this non-example we see one of them. And then we get a term like this. Let me also write this in red. So we get dz dx times dx dt. Right, this is going down this branch, dz dx times dx dt. And then what you do is you add all the possible other branches that end in t. In this little non-examples there are none, but this is in general what you do. So that will be the next step of how to apply the chain rule. And then in the final step you want to take things like dz dx. Well, we know that this dependency is given by f. So for instance dz dx here, what I wrote, that's going to be equal to the f sub x in the point xy. So you want to substitute the dependencies of which you know the names of the functions, and that will then give you the final answer. Okay, so let me erase the red part, because that is not how it works in this example, but that was just to give you an idea how the general procedure works. Okay, so what I want you to do now is to pause the video and do these two steps. So first finish the tree, then identify all the branches from z that end in t, and then write down the expression as a sum of these branches, and then plug in what you know about the dependencies. So please pause the video and do this, and I will be back in a second to give you the solution. Okay, so let us finish the tree first. So we have x and y here. Well, we see that x depends on u and v. So let's write this down. So x depends on u and v. And this dependency is given by the function g. What about y? Well, y only depends on u. So we only have a single path here. Y depends only on u, and this is again given by the function h. Okay, what about u? Well, u, as we see here, depends on s and t. V only depends on t. So u depends on s and t, and v only depends on t. And u again depends on s and t. So these are given by explicit functions, so I don't write a letter here because these are explicit. Okay, so that finishes building the tree. So now for the next step, we need to identify all the branches from Z that start in Z and that end in T. For instance, if you go through the leftmost part, we see we can go like this to T. So that's one possible branch. So let's write this in red. Let's do it like this. Yeah, that's one possible branch from Z to T. Another one, we can go down here and we also end up in T. So we can take a detour and we go like this. So that's the second branch. And then we see that the third branch is over here where it also ends in T over there. Right, so we see we have 3 branches. Okay, now so let's write down what we get. So we have dz dt. So let's take the leftmost branch, so that's dz, let's point at it. So it's from z to x, then it's from x to u, and then it's from u to t. So it's dz dx times dx du times du dt. Now we go to the second branch, which is this one. From z to x, from x to v, and from v to t. So dz dx times dx dv times dv dt. And then the last one, which is the rightmost one, is from z to y, from y to u, and from u to t. dz dy dy du du dt. Okay, so that finishes that step. And then all we need to do is the final step where we basically plug in the dependencies and we write it out. We write out all that we know as far as possible, basically. So we use all our knowledge. So dz dx. Okay, so this dependency is given. We can see this in the tree as well by f. So this is going to be, so the dz dx is going to be the f sub x, the derivative of f with respect to the first variable, the x variable. Then the x du, well, that's the derivative of f with respect to the first variable u, and that function is given by g. So this is going to be the derivative of g with respect to the first variable, which is u. And then the last du dt, well, this can be computed explicitly because this is given explicitly. So this is 2s squared t. Next one, dz dx, we discussed that before, that's f sub x. The x dv, so that's over here, that's given by the function g, so it's the derivative of g with respect to the v variable, so that's g sub v. And then dv dt, that's also given explicitly, that's 3t squared. And then the last one, dz dy, so similar as before, this is now the derivative of f with respect to the y variable. Then dy du, well, y is only a single variable, so if you want you could write h sub u, but it would be a little bit more accurate to write h prime of u, because we only have a single variable and then we always denote the derivative with a prime. So this is, I think, the most accurate way of writing it down. And then we have du dt, which is, as before, is 2s squared t. And so that is a nice expression for dz dt, and this finishes this video on the chain rule.